Okay guys, let's have a look at 14, which doesn't look very nice at all, does it? So let's have a look at it. We've got 16 minus 54 plus 128 minus 250 and plus. So we've got alternating signs to take care of amongst a whole host of other things. Now the other thing I've noticed straight away is 54 is 27 times 2. And that is the key. If you notice that's 27 times 2, then you'll notice that this is 64 times 2. And you know 64 and 27. And this is 8 times 2, so that looks good. And this is 125 times 2, isn't it? So let's just take out 2 first of all. It's 2 8s minus 2 times 27 plus 2 times 64 minus 2 times 125. Yeah? Plus dot dot dot. So that's equal to then. Now the 8 I can write as 2 cubed, so it's 2 times 2 cubed. Minus 2 times 3 cubed, isn't it? Because that's 27. Plus 2 times 4 cubed. Minus 2 times 5 cubed, which is 125 plus dot dot dot. Good. So the pattern is starting to emerge then, isn't it? The only thing now looks like we need to take care of is the alternating signs. So let's just do that on the next line. This would be minus 1 to the 0 times 2 cubed, wouldn't it? Then it would be minus 1 to the power 1 would give us a minus. 2 times 3 cubed. Then we'd need a minus 1 squared, don't we? And 2 times the 4 cubed. And then it's minus 1 cubed would give us the minus. Times 2 times 5 cubed plus dot dot dot. So, good. So what have we got then? We've got 2 is constant all the way through. So it's 2, and then it's cubed is constant all the way through, isn't it? But the 2, 3, 4, and 5. So it's 2, 3, 4, and 5. So that's the r, isn't it? So this would be 2r cubed. And the minus 1, and it was r when r was 2, this was. And we've got 0 here. So I need to do 2 less. Agreed? Okay, so plus minus 1, and then it would be 2 times r cubed when r is 3, and this would be r, 3 minus 2 would give you 1, which is what you wanted, plus, and then it's minus 1. So can you see, you should be fairly happy now just to write this down. When r equals 4, and that will give you 2 there. Yeah, that's fine, everything's fine there. And the last term, just to be absolutely happy with this, minus 1 to the r minus 2s, times by 2 times r cubed when r equals 5, and that will give you the term above. Good. Now, what have we got then? Now I'm going to tweak this when I write down the sigma notation. It's 2r cubed, yeah? Now instead of writing r minus 2, this will stay the same value if I add powers of 2, because I'm just timesing by 1 in effect. Minus 1 to the 2, so I can increment this power and it still have the same sign. So it looks easier on the eye if we just write that as minus 1 to the r. I'm just adding 2, and it gives you the same value. So this would be correct if you just put r minus 2, but this looks easier on the eye. We started from 2, and it's an infinite sequence. There we go. So that's the answer there, in sigma notation. If you want to put minus 2, you can, but I just relied on the fact that here, that minus 1 to the r is equal to minus 1 to the r minus 2 times minus 1 squared. Yeah, agreed? Using properties of indices. And minus 1 squared is just 1. So that's 1 lot of minus 1 to the r minus 2. So you can add a power. That's what I'm saying here. You can add a power, add 2 to a power, an index of the minus 1s. You can add 2 if it looks easier on the eye, which it did here. Okay, then that's 14 done. Good.